Something is pulsing out there. Every 16 hours and 16 minutes, the interstellar visitor we call 3i Atlas breathes. Not metaphorically, not poetically. The light coming off this object rises and falls with a rhythm so consistent, so measured, that Harvard astrophysicist Avi Loeb is now asking a question that should make every one of us sit up a little straighter. Is this object beating like a heart? And if so, what exactly is pumping the blood? Because here is what the mainstream astronomers do not want you to think about too carefully. The jets streaming off 3i Atlas, those brilliant plumes of gas and dust shooting towards and away from the sun, they are not behaving randomly. They are not chaotic. They pulse. They repeat. And the physics required to explain that behaviour naturally is starting to stretch credibility to its breaking point. 17 days from now, on December the 19th, this object will make its closest approach to Earth. After that, it leaves forever. We have 17 days to understand what is visiting us, and the clock is ticking. Before we dive in, if you enjoy these deep dives into the cosmos, hit like and subscribe, but only if you find yourself truly enjoying my videos. Now tell me in the comments, where are you listening from, and what time is it there? Let's begin. The story of 3i Atlas has been unfolding for 5 months now, and in that time we have documented anomaly after anomaly. But the latest development, published just days ago, adds something new to the picture, something that changes how we need to think about this object. Avi Loeb, the Baird Professor of Science at Harvard University and former chair of the astronomy department, has been tracking every piece of data coming in from observatories around the world. His latest analysis focuses on something that was noticed early but never fully explained. The brightness of 3i Atlas varies. It pulses. The period of that pulsation is 16.16 hours, measured with an uncertainty of only plus or minus 0.01 hours. That is extraordinarily precise, and the amplitude of that variation is not subtle. We are talking about changes of tens of % in the total light output. Now, the conventional explanation offered when this periodicity was first detected was simple enough. The object must be elongated, shaped something like an ellipsoid with an axis ratio of about 0.8. As it rotates, we see more or less of its reflective surface, and the brightness changes accordingly. Case closed, except it is not closed at all. Because here is what that explanation conveniently ignores. The Hubble Space Telescope imaged 3i Atlas on July 21st of this year. And what that image revealed is that most of the light we observe from this object does not come from the nucleus itself. It comes from the coma, that glowing halo of gas and dust surrounding the solid core. The coma is transparent. You can see the nucleus through it, but the coma dominates the total brightness. So if the brightness variations are not primarily caused by the rotating shape of the nucleus, what is causing them? This is where Loeb's analysis becomes genuinely unsettling. Over the past month, images of 3i Atlas have revealed multiple jets streaming off the object. We have discussed these jets before, the anti-tail pointing toward the sun, the longer tail streaming away, the network of collimated outflows extending millions of kilometers into space. What Loeb is now proposing is that the 16-hour periodicity and brightness is not about the shape of the nucleus at all. It is about the jets themselves. Picture this. Somewhere on the surface of 3i Atlas there is a region, perhaps a pocket of ice, perhaps something else entirely, that faces the sun once per rotation. When that region points toward our star, something happens. A jet activates. Material streams outward. The coma, that glowing envelope, gets pumped up with fresh gas and dust. And then, as the object rotates, and that active region turns away from the sun, the jet subsides. The coma gradually dims until the next rotation brings that region back into solar view. Loeb describes this as a heartbeat, a puff of gas and dust serving the role of blood, streaming through the coma periodically with each rotation cycle. Think about what this means. If the jets are pulsed, if they activate and deactivate with clockwork precision tied to the rotation of the object, then we are not looking at random outgassing. We are looking at a mechanism. Something is controlling when and how material leaves this object. For a natural comet, this could be explained by localized pockets of volatile ice that sublimate only when heated by direct sunlight. Carbon dioxide ice, for instance, transitions directly from solid to gas when warmed. If there is a concentrated deposit of such ice on one face of the nucleus, you would expect periodic outbursts tied to rotation. That is the conventional explanation, and it might be correct. But here is where the physics starts to get uncomfortable. Assuming an outflow velocity of 440 meters per second, which is the figure suggested by James Webb Space Telescope observations, you can calculate how far the sublimated material would travel during one rotation period. 16.16 hours at that velocity gives you a distance of about 25,600 kilometers. That is the heartbeat pattern. That is the spatial signature you would expect to see in the coma if this pulsing mechanism is real. And here is the problem. No one has systematically studied whether this pattern actually exists. Loeb points out that a series of well-calibrated snapshots of the coma taken over several days should reveal this heartbeat structure if it is there. But that analysis has not been done. Or if it has been done, it has not been published. The data exists. The telescopes have been watching. But the scientific community seems curiously uninterested in asking this particular question. Now, I want to be careful here. Loeb himself acknowledges that a natural explanation is possible. Pulsed jets from localized ice pockets would be unusual but not impossible. What makes this situation different is context. 3i Atlas is not showing us one anomaly. It is showing us 12, and they are compounding. The anti-tail that points toward the sun when every known comet points its tail away. The jets that remain tightly collimated across millions of kilometers despite the object's rotation when they should be smeared into diffuse fans. The trajectory aligned within 5 degrees of the ecliptic plane with a probability of only 0.2%. The mass 1,000,000 times greater than Oumuamua and 1,000 times greater than Borisov, while moving faster than both. The timing that brought it close to Mars, Venus and Jupiter while making it unobservable from Earth during perihelion. Each anomaly alone might be dismissed. Together, they form a pattern that demands explanation. And now we add the heartbeat. Now we add the possibility that the jets themselves are not random but controlled, not chaotic but rhythmic, not natural but perhaps, just perhaps, something else entirely. The Webb telescope measured the composition of the outflow: 87% carbon dioxide, 9% carbon monoxide, about 4% water. The mass loss rate at a distance of 3.32 astronomical units from the Sun was approximately 150 kilograms per second. These are concrete numbers. They can be modelled. And when you model them, you find something strange. The surface area required to absorb enough sunlight to sublimate that much ice is unreasonably large. The math does not quite work for a natural comet of the size we believe 3i Atlas to be. This was already documented as one of the 12 anomalies. The object exhibits mass flux that requires more surface area than it appears to have. So what are we looking at? The skeptics will tell you it is a comet. They will point to the coma, the tail, the spectroscopic signatures of familiar volatiles. And they are not wrong that these features exist. But they are wrong if they think those features settle the question. Because a sufficiently advanced technology, if it wanted to disguise itself, would look exactly like what we expect to see. It would produce gas, it would form a coma, it would grow a tail. The camouflage would be perfect precisely because we would not think to look deeper. Loeb has been clear about this from the beginning. He is not claiming 3i Atlas is artificial. He is claiming we do not have enough evidence to rule it out. And ruling it out prematurely, based on pattern matching to familiar objects, is not science. It is assumption dressed up as expertise. The heartbeat adds another layer to this mystery. If the jets are pulsed naturally, we should be able to predict exactly what the coma looks like at any given moment. The spatial distribution of material should follow calculable patterns based on outflow velocity and rotation period. Those predictions can be tested. The data to test them exists. So why has no one published that analysis? Why, with the most observed interstellar object in human history approaching its final observation window, is the scientific community not racing to answer these questions? I do not know. But I suspect the answer has more to do with sociology than science. Some questions are uncomfortable, some possibilities are career, ending to take seriously, and some truths, if they turn out to be truths, would change everything. In the coming days, as 3i Atlas approaches its December 19th closest approach to Earth, we will get our best and final look at this visitor. The Hubble telescope will observe, the Webb telescope will observe, ground-based observatories around the world will train their instruments on this object, and somewhere in that flood of data, the answer to the heartbeat question exists. Is it natural periodicity from localized ice sublimation, or is it something else, something rhythmic and controlled and purposeful? We have 17 days to find out. But the heartbeat is not the only revelation from the past 72 hours, because while Loeb was analysing the pulsation data, another team of researchers was making a discovery that adds an entirely new dimension to this mystery. They found ice volcanoes, cryovolcanic eruptions on an interstellar comet, and what those eruptions tell us about the composition of 3I Atlas challenges everything we thought we knew about where this object came from and what it is made of. That discovery, and its stunning implications, is where we turn next. Ice volcanoes from another star. The images arrived on November 24th, captured by the Joan Oro telescope at the Montsec Observatory in northeastern Spain. What they revealed was unlike anything astronomers had seen on an interstellar object before. Spiral jets, corkscrew patterns of gas and dust erupting from the surface of 3I Atlas, with a structure so defined, so organised, that the research team could reach only one conclusion. We are witnessing cryovolcanism, ice volcanoes erupting on a visitor from another star system, and the implications of that discovery stretch far beyond the spectacular imagery. Josep Trigo Rodriguez, a leading researcher at the Institute of Space Sciences in Spain, led the study. His team had been tracking 3I Atlas obsessively as it approached perihelion, that critical closest approach to the Sun that occurred on October 29th. They knew that as the comet heated up, its behaviour would change, ice would sublimate, jets would form. But what they captured exceeded their expectations. The highest resolution images yet obtained of 3I Atlas showed not random outgassing but organised eruptions. The jets were spiralling, they were structured, they bore the unmistakable signatures of cryovolcanic activity. Now, cryovolcanoes are not unknown in our solar system. We have observed them on trans-Neptunian objects, those distant dwarf planets and icy bodies that orbit beyond Neptune in the cold outer reaches of our cosmic neighbourhood. Pluto has them, Triton has them. These ice volcanoes work differently than the molten rock volcanoes we know on Earth. Instead of magma, they erupt with volatile substances like water, ammonia, or methane. Internal heat generated by radioactive decay or tidal forces melts subsurface ice. Pressure builds, and eventually the volatile material erupts through the surface, creating plumes of vapour and ice particles that spray into space. But here is what makes the discovery on 3I Atlas so remarkable. This object is not from our solar system. It formed around another star in conditions we can only guess at billions of years ago. And yet, as it passes through our inner solar system and heats up under our sun's radiation, it is behaving exactly like a trans-Neptunian object would. The cryovolcanism is being driven by the same mechanism we see in our own outer solar system. As the sun heated 3I Atlas, the threshold for solid carbon dioxide to sublimate was breached. Dry ice began transforming directly into gas, but that was just the trigger. According to Trigo Rodriguez and his team, the sublimation enabled something else to happen. An oxidizing liquid began flowing into the comet's interior, reacting with metallic grains like nickel and iron sulfides locked within the pristine material. That chemical reaction generated additional heat and pressure, driving the cryovolcanic eruptions we see in the images. Think about what this tells us. 3I Atlas is not a simple ball of ice. It has internal structure, it has chemistry, it has processes occurring beneath its surface that are producing organised structured eruptions. The spiral pattern of the jets is not accidental. It emerges from the interaction between the comet's rotation and the localised venting of material from specific active regions. As the object spins, the erupting material traces out those characteristic corkscrew shapes. It is beautiful, it is alien, and it is giving us a window into the composition of a body that formed in a completely different stellar environment. The research team went further. They wanted to understand what 3I Atlas is actually made of, so they conducted spectroscopic comparisons using some of the most pristine samples available on Earth. Carbonaceous chondrites. These are primitive meteorites, rocky remnants from the earliest days of our solar system that have remained largely unchanged for 4.5 billion years. NASA has collected numerous specimens from Antarctica, where the cold, dry conditions preserve them, beautifully. Among those Antarctic samples, some are believed to contain fragments of trans-Neptunian objects, pieces of the distant icy bodies that occasionally get scattered into the inner solar system. When Trigo Rodriguez compared the spectroscopic signature of 3I Atlas to these carbonaceous chondrite samples, he found something stunning. The match was remarkably close. Despite coming from another star system entirely, 3I Atlas appears to share compositional characteristics with the most ancient pristine materials in our own solar system. It resembles trans-Neptunian objects. It behaves like trans-Neptunian objects. And now, with the discovery of cryovolcanism, it is erupting like trans-Neptunian objects. The implications here are profound. If 3I Atlas is compositionally similar to our own outer solar system bodies, it suggests that the processes that formed icy objects in our cosmic neighbourhood may be universal. The same chemistry, the same materials, the same structures might arise around stars throughout the galaxy. We are not looking at something completely foreign. We are looking at a cousin, a distant relative formed under different circumstances but built from the same cosmic recipe. But wait. Before we settle too comfortably into that interpretation, we need to consider what the cryovolcanism also reveals about the mysteries that remain unexplained. Because the composition data includes something that does not fit the trans-Neptunian comparison quite as neatly: nickel. 3I Atlas is showing nickel-dominant emissions with unusually low iron content. For a comet approaching the Sun, for any icy body heating up and outgassing, this is not what scientists expected to find. The nickel-to-iron ratio is atypical. It stands out. Carbonaceous chondrites do contain nickel. They contain iron sulfides. The chemical reactions driving the cryovolcanism would indeed release these elements. But the proportion is strange. And when you add this to the growing list of anomalies, when you consider that the antitail is still present, that the jets maintain their collimation despite rotation, that the mass loss rate implies an impossible surface area, the picture becomes less clear rather than more. Here is the tension at the heart of this discovery. On one hand, the cryovolcanism suggests 3I Atlas is a natural object behaving in ways we can understand through known physics. It is an icy body with internal structure, responding to solar heating through familiar thermodynamic processes. That should be reassuring. That should make us confident we are looking at a comet and nothing more. On the other hand, the organised nature of those eruptions, the structured spiral jets, the precise periodicity we discussed in the previous chapter, the heartbeat rhythm of the outgassing, all of this points to a level of order that keeps raising questions. Natural systems can be ordered. Crystals have structure, planetary rings have organisation, but natural systems also tend toward entropy. They tend toward chaos over time. 3I Atlas has been travelling through interstellar space for billions of years, bombarded by cosmic radiation, subjected to the cold vacuum, isolated from any stabilising influences. And yet it arrives in our solar system with this level of structural integrity and organised behaviour. Trigo Rodriguez himself noted that the comet is rich in natural metal. That composition is consistent with what his team calls a metal-bearing, carbonaceous and pristine interstellar comet. The word pristine keeps appearing in the scientific literature. It means unspoiled, unaltered, original. But how does something remain pristine across billions of years of interstellar travel? How does it maintain the structural integrity necessary to produce organised cryovolcanic eruptions, rather than simply falling apart when heated? One possibility is that 3I Atlas has a coherent internal structure. Perhaps it formed as a single body rather than as a loose aggregate of smaller pieces. Perhaps its metallic content provides a kind of structural reinforcement, holding it together where a more porous object would fragment. This would be unusual, but not impossible. We simply do not have enough data on interstellar objects to know what is normal and what is anomalous. We have seen exactly 3 of them. Oumuamua was strange in its own ways. Borisov was more comet-like but still raised questions. And now 3I Atlas is strange in completely different ways. The cryovolcanism discovery also connects to another mystery we have been tracking: the mass estimate. Based on the lack of detectable non-gravitational acceleration in its trajectory, 3I Atlas was calculated to possess a mass larger than 33 billion tons. That is enormous. It is 1,000,000 times more massive than Oumuamua and 1,000 times more massive than Borisov. An object of that mass, made of the materials suggested by the spectroscopic analysis, would need to be quite dense, quite solid, quite structurally coherent, and an object that coherent would be exactly the kind of body capable of sustaining organised cryovolcanic activity, rather than simply shedding material chaotically. So the pieces fit together in a way that supports a natural explanation, but they also fit together in a way that supports something else. Because if you wanted to build an object capable of withstanding interstellar travel, capable of appearing natural while passing through a foreign solar system, capable of producing activity that looks like cometary behaviour, you would build something very much like what we are observing. You would give it an icy exterior that responds to stellar heating. You would give it internal structure that produces organised outgassing. You would make it massive enough to maintain trajectory stability. You would, in short, make it look like an unusually robust trans-Neptunian object. I am not saying that is what 3I Atlas is. Neither is Avi Loeb. Neither is anyone with scientific credibility. What we're saying is that the question remains open. The cryovolcanism is spectacular confirmation that this object is geologically active in ways we can partly understand. But it does not close the door on the deeper mysteries. It does not explain the anti-tail. It does not explain the jet collimation. It does not explain the trajectory alignment, or the timing of arrival, or any of the other statistical improbabilities that have accumulated over the past 5 months. What it does do is give us more data, more observations, more constraints on what 3I Atlas might be, and that is exactly what science requires. We do not need premature conclusions. We need evidence. We need careful analysis. We need the humility to admit when we do not know something, and the courage to keep asking questions even when those questions make the establishment uncomfortable. The ice volcanoes are real. The cryovolcanism is happening, and somewhere in those spectacular spiral jets, in those organised eruptions from another star, there may be answers to questions we have not yet thought to ask. But there is another aspect of 3I Atlas that we have only touched on briefly, an anomaly so persistent and so strange that it has defined this object since its earliest observations, the anti-tail. That impossible plume pointing toward the sun when everything we know about comets says it should point away. The physics of that feature and why it continues to defy easy explanation is where we go next. The anti-tail that defies physics. Every comet you have ever seen in a photograph, every depiction in art, every childhood drawing shows the same thing. A bright head with a tail streaming behind it, pointing away from the sun. This is not artistic convention. It is physics. The solar wind, that constant stream of charged particles flowing outward from our star at 400 kilometers per second, pushes cometary material away from the sun. Solar radiation pressure does the same thing. Light itself carries momentum, and when photons strike the tiny dust particles in a comet's coma, they transfer that momentum, pushing the dust in the anti-solar direction. This is why comets have tails. This is why those tails always point away from the sun, except when they do not, except when you're looking at 3I Atlas. The Hubble Space Telescope captured the first clear image of this anomaly on July 21st. The object was 277 million miles from Earth, still approaching the sun, and the image revealed something that made comet experts pause. The glowing material around 3I Atlas was not streaming away from the sun. It was pointing toward it, an anti-tail, a sunward jet, a feature so unexpected that when the image was first released, many astronomers assumed it must be a perspective effect, an optical illusion created by a viewing angle rather than a real physical phenomenon. But it was real, and it is still there. Images taken as recently as November 29th continue to show a prominent anti-tail extending toward the sun, alongside the conventional tail pointing away. 2 jets, 2 directions, one object doing something that comets are not supposed to do. Let me be precise about what we are seeing, because the details matter. When Hubble imaged 3I Atlas in July, the viewing angle was only 10 degrees away from the direction of the object relative to the sun. This means we were looking almost head-on at the sunward side. If the anti-tail had been an optical illusion from geometric perspective, if it was just normal tail material that appeared to point sunward because of our viewing angle, then the apparent elongation would have been modest. Instead, the image showed a pronounced elongation with a projected ratio of 2:1. When corrected for the viewing angle, that elongation becomes approximately 10:1 in 3 dimensions. We are not looking at a subtle effect. We are looking at a jet, a structured outflow pointing directly at the sun with an aspect ratio resembling a focused beam rather than a diffuse cloud. Avi Loeb and his colleague Eric Quito developed a model to explain this. Their proposal was that the sunward jet is dominated by water ice fragments ejected from the nucleus as a result of carbon dioxide sublimation. The physics works like this. When carbon dioxide ice sublimates, it releases energy and can carry larger particles with it. Water ice, which has a higher sublimation temperature, would not vaporize at the distances where 3I Atlas was observed. Instead, it would remain as solid fragments, tiny chunks of ice launched off the surface by the erupting carbon dioxide. These fragments would be much larger and more massive than typical cometary dust. Their effective radius would be around 100 micrometers, making them about 1,000,000 times more massive than the micrometer scale particles that scatter sunlight most efficiently. Why does size matter? Because larger particles are less affected by solar radiation pressure. The force of sunlight pushing against a particle depends on the cross-sectional area, but the particle's inertia depends on its mass. For very small particles, the radiation pressure dominates, and they get swept away from the sun almost immediately. For larger particles, inertia wins. They continue on ballistic trajectories determined primarily by gravity and their initial velocity. If 3I Atlas is ejecting large ice fragments toward the sun, those fragments would not be pushed back. They would continue sunward until gravity eventually curves their paths. This creates the anti-tail. The model is elegant, it is physically plausible. And when Loeb and Quito extended their analysis to track how the anti-tail should evolve over time, their predictions matched observations. As 3I Atlas approached the sun, the anti-tail did transition. By September, images from the Nordic Optical Telescope showed the feature had diminished, replaced by a growing conventional tail in the anti-solar direction. The physics seemed to be working. The mystery seemed to be solved. Except it was not. Because after perihelion, after 3I Atlas swung around the sun on October 29th, the anti-tail came back. Images from November 8th, November 9th, November 15th, November 22nd, and November 29th all show the same thing. A prominent sunward extension alongside the tail. The feature did not disappear. It persisted. And the physics required to explain that persistence is starting to strain credibility. Here is the problem. For a natural comet, the anti-tail requires specific conditions. You need large particles being ejected with enough velocity to overcome immediate gravitational fallback. You need those particles to maintain coherence rather than dispersing into an invisible diffuse cloud, and you need the ejection mechanism to continue operating consistently over months of observation. 3I Atlas has now shown anti-tail features in July, August, and again in November. That is remarkable longevity for a phenomenon that depends on such specific conditions. But there is an even stranger aspect to consider. The anti-tail from 3I Atlas extends an extraordinary distance. Recent images show it reaching out to approximately 1,000,000 kilometers from the nucleus. At the same time, the conventional tail extends to around 5,000,000 kilometers in the anti-solar direction. These are enormous structures. The anti-tail alone would stretch more than twice the distance from Earth to the Moon, and maintaining that structure requires something pushing against the solar wind. Think about what that means. The solar wind is flowing outward at 400 kilometers per second. It carries its own momentum, its own pressure. Anything in the sunward direction has to push back against that pressure to maintain position. The anti-tail's ram pressure, the momentum flux it carries, must exceed the ram pressure of the solar wind at distances up to 1,000,000 kilometers from the nucleus. That requires extraordinary density in the outflow. Loeb calculated that the outermost mass density in the anti-tail must be about 1,000,000 times greater than the typical solar wind density of a few protons per cubic centimeter. For a natural comet, achieving and maintaining that density over such distances implies a mass flux of around 200 tons per second through an area roughly 300,000 kilometers on a side. Add that up over 2 months of observation, and you get a total mass loss of a few billion tons. That is a substantial fraction of the object's total mass, which was estimated at more than 33 billion tons. Is it possible for a natural comet to shed that much material while maintaining structural integrity and continuing to produce organized jets? Possibly. But it strains the models. There is another explanation for anti-tails in cometary physics, and it has nothing to do with large particles. Comet Kohoutek, discovered in 1973, showed a similar sunward enhancement in certain observations. Astronomers at the time explained it through geometric effects related to the viewing angle and the distribution of ejected material. Pennsylvania State astronomer Jason Wright has cited this example in pushing back against Loeb's claims, arguing that anti-tails are not unique to 3I Atlas and do not require exotic explanations. He is right that anti-tails can occur. He is right that geometric effects matter. But here is what his argument misses. The anti-tail of 3I Atlas aligns with its rotation. The feature changes shape subtly during rotational cycles, as documented in the spin wave analysis that amateur astronomers have been conducting. This alignment between the anti-tail geometry and the rotational behaviour suggests the two phenomena are connected. The sunward jet is not a random artefact of viewing angle. It is locked to the physical structure and motion of the object itself. Furthermore, the jets from 3I Atlas remain tightly collimated across distances exceeding 1 million kilometres. This was identified as the 12th anomaly on Loeb's list. When an object rotates, as 3I Atlas does with its 16.16-hour period, material ejected from fixed points on the surface should spread out over time. The rotation should smear the jets into diffuse fans. Instead, the images show razor-sharp structures maintaining their orientation across vast distances. Either the ejection mechanism compensates for rotation somehow, or the jets are not originating from fixed surface locations in the way we would expect for a natural comet. I want to pause here and acknowledge the tension in this analysis. The evidence supports multiple interpretations. The anti-tail could be explained by large ice fragments, unusual but not impossible for a natural comet. The collimation could result from specific outflow conditions we do not fully understand. Each anomaly, taken individually, has a potential natural explanation. The question is whether those explanations stacked together remain plausible. Because we are not looking at one strange feature. We are looking at a constellation of strange features all appearing on the same object. The anti-tail points toward the sun. The jets stay collimated despite rotation. The mass loss implies an impossibly large surface area. The trajectory aligns with the ecliptic to a statistically improbable degree. The arrival timing brought the object close to Mars, Venus and Jupiter, while hiding it from Earth during perihelion. The brightness pulses with clockwork periodicity. The composition shows unusual nickel enrichment. The cryovolcanic eruptions produce organised spiral patterns. And now, after surviving the intense solar heating of perihelion, the object remains intact as a single body when many comets would have fragmented. Each of these could be coincidence. All of them together start to look like something else. Loeb has proposed an alternative interpretation for the anti-tail that he acknowledges is speculative but cannot be ruled out by current data. Technological thrusters. If 3I Atlas were an artificial object, a spacecraft of some kind, then exhaust directed toward the sun would accelerate the object away from the sun. This is basic Newtonian physics, action and reaction. A thruster pointing sunward would produce exactly the kind of anti-tail we observe, while simultaneously providing propulsion for a post-perihelion escape maneuver. He's careful to note that this is not his primary hypothesis. The natural comet explanation remains more likely given our current understanding. But science requires considering all possibilities that fit the data, and a technological explanation fits. That should not be dismissed simply because it is uncomfortable. In 17 days, 3I Atlas reaches its closest approach to Earth. In that window, the most powerful telescopes on the planet and in orbit will gather the highest resolution data we will ever obtain on this object. The anti-tail will be visible, its structure will be measured, its evolution will be tracked, and somewhere in that data there may be evidence that finally distinguishes between the natural and the extraordinary. But the anti-tail is only one piece of a much larger puzzle, because Loeb has not just documented 1 or 2 anomalies, he has documented 12 distinct features of 3I Atlas that fall outside normal expectations, 12 mysteries that together paint a picture of an object unlike anything we have encountered before. Understanding how those anomalies compound and what they mean collectively requires stepping back and looking at the full scope of what we're dealing with. That comprehensive view is where we turn next. 12 mysteries and counting. Let me take you through something that should not exist. A list. 12 items long, each one representing a feature of 3I Atlas that falls outside the boundaries of what we expect from natural comets. Individually, any one of these could be dismissed as unusual but not impossible. Together, they form a pattern so improbable that honest scientists are forced to admit we might be looking at something unprecedented. Avi Loeb has been documenting these anomalies since July, updating his list as new observations arrive. As of late November, that list stands at 12. Let us walk through them one by one and understand what each one means. Anomaly number 1. The trajectory of 3I Atlas is aligned to within 5 degrees of the ecliptic plane, the orbital plane shared by all the planets around our Sun. This sounds technical, so let me explain why it matters. Objects entering. Our solar system from interstellar space should arrive from random directions. The galaxy is three-dimensional. Stars are distributed throughout a roughly disc-shaped structure, but individual stellar systems have random orientations relative to each other. An interstellar object ejected from another star system should approach our Sun from essentially any angle. The ecliptic plane represents a specific orientation, the plane in which Earth and the other planets orbit. For an interstellar object to align with that plane by chance, the probability is only about 0.2%, 1 in 500. 3I Atlas did not arrive from some random angle. It arrived almost exactly aligned with the orbital plane of our planets. And not only that, it is moving retrograde, opposite to the direction the planets orbit. It is threading the needle while going the wrong way. Anomaly number 2, the sunward jet, the anti-tail we discussed in detail. During July and August, and again in November after perihelion, 3I Atlas displayed a jet pointing toward the Sun rather than away from it. This is not an optical illusion from viewing geometry. The Hubble images confirmed a physical structure extending sunward with a three-dimensional aspect ratio of approximately 10:1. Natural comets do not do this. Not like this. Not with this persistence. Anomaly number 3. The mass of 3I Atlas is approximately 1,000,000 times greater than Oumuamua and 1,000 times greater than Borisov, while its velocity exceeds both. Think about what this implies. If you are randomly sampling interstellar objects, you would expect a distribution of sizes and velocities. Finding the largest and fastest one in just the third detection is statistically unusual. The probability that the first 3 interstellar objects we detect would show this distribution is less than 0.1%. We are either extraordinarily unlucky in our sampling, or something is selecting for these characteristics. Anomaly number 4. The arrival timing of 3I Atlas was exquisitely fine-tuned. Its trajectory brought it within tens of millions of kilometers from Mars on October 3rd. It will approach Venus and Jupiter on its outbound path, and during perihelion, its closest approach to the Sun on October 29th, it was positioned precisely where it would be unobservable from Earth, hidden behind our star. The probability of this geometric arrangement occurring by chance is estimated at 0.005%, 1 in 20,000. The object arrived at exactly the right time to visit multiple planets while avoiding detailed observation from Earth during its most active period. Anomaly number 5. The composition of 3I Atlas shows extreme enrichment in nickel with anomalously low iron content. For a comet approaching the Sun, for any icy body undergoing thermal processing, this ratio is unexpected. Nickel and iron typically occur together, in meteoritic materials and cometary dust. Finding nickel-dominant emissions without corresponding iron signatures suggests unusual source material, or unusual processing. The spectroscopic data does not match typical cometary profiles. Anomaly number 6. The cryovolcanic activity we discussed produces spiral jet structures indicating organized eruptions from localized regions. While cryovolcanism itself is not unprecedented, the degree of organization and the resemblance to trans-Neptunian object behavior in an interstellar visitor is noteworthy. The object is demonstrating internal structure and activity patterns that suggest significant compositional complexity. Anomaly number 7. The brightness of 3I Atlas pulses with a period of 16.16 hours and an amplitude of tens of percent. This periodicity has been attributed to rotation, but as we discussed, the brightness variations are dominated by the coma, not the nucleus. If the periodicity reflects pulsed jet activity rather than simple shape effects, it implies a controlled or organized outgassing mechanism tied to specific surface features. Anomaly number 8. Near perihelion, 3I Atlas exhibited non-gravitational acceleration. Its trajectory showed deviations from what pure gravitational motion would predict. While comets commonly show non-gravitational effects due to outgassing, the magnitude and characteristics of the acceleration observed in 3I Atlas require massive evaporation of at least 13% of its total mass. This is an enormous amount of material to lose while maintaining structural integrity. Anomaly number 9. Despite the intense solar heating at perihelion, 3I Atlas did not break up. It survived as a single body. Many comets fragment when approaching the Sun. The thermal stresses, the pressure differentials from uneven heating, the loss of volatile material, all of these factors tend to cause structural failure. 3I Atlas emerged from perihelion intact. Images from November show a single nucleus with no evidence of fragmentation. For an object experiencing the mass loss rates implied by its jets, this structural resilience is remarkable. Anomaly number 10. The jets from 3I Atlas require an unreasonably large surface area to absorb enough sunlight to sublimate the implied mass flux. The math does not add up. If you calculate how much solar energy is available at the object's distance from the Sun, and you calculate how much ice needs to sublimate to produce the observed jets, you find that the surface area required exceeds what an object of 3I Atlas's estimated size should have. Either the size estimates are wrong, or the energy is coming from somewhere other than solar heating. Anomaly number 11. As mentioned, the object exhibits non-gravitational acceleration requiring massive evaporation, while preliminary images show it maintained integrity and did not break up. These two observations are observations. Intention. Massive outgassing should destabilize a loosely bound body. Yet 3I Atlas appears neither loosely bound nor destabilized. Anomaly number 12. The jets maintain their orientation across distances exceeding 1 million kilometers, despite the object's measured rotation. This is the collimation problem. A rotating body ejecting material from fixed surface vents should produce jets that spread into fan shapes as the ejection point moves. The rotation period is 16 hours. The jets extend millions of kilometers. The time required for ejected material to reach those distances at observed outflow velocities is comparable to, or longer than, the rotation period. The jets should be smeared. They are not. 12 anomalies, 12 features that push against the boundaries of what we consider normal cometary behavior. Now, I want to be intellectually honest here. None of these anomalies, individually or collectively, prove that 3I Atlas is anything other than a natural object. Each one has a potential natural explanation, even if that explanation requires unusual circumstances. The trajectory alignment could be coincidence. The anti-tail could be large particle dynamics. The mass could simply reflect the diversity of interstellar objects. The timing could be random chance that we are pattern matching into significance. The composition could reflect alien but natural stellar chemistry. The structural integrity could indicate a denser, more coherent body than typical comets. But here is the question that keeps me awake at night. How many coincidences are too many? At what point does the accumulation of improbabilities become itself improbable? If each anomaly has a 1% chance of occurring naturally, and they are independent, then 12 such anomalies appearing together has a probability of 1 in 10 to the 24th power. That number is so small it is essentially zero. Of course, the anomalies are not independent. Some relate to others. Some may have common explanations. The real probability is much higher than that naive calculation suggests, but it is still low, uncomfortably low. Avi Loeb uses a framework he calls the Loeb scale to quantify how anomalous an object appears. The scale runs from 0 to 10, with 0 indicating completely normal behavior and 10 indicating confirmed artificial origin. Based on the 12 anomalies documented so far, Loeb has rated 3I Atlas at level 4. That means increasingly anomalous characteristics that warrant serious investigation, while still most likely being natural. He has been clear about what would change that rating. If the measured speed, composition, and mass flux of the jets are consistent with sublimation of volatiles from pockets of ice on a natural comet, he will reduce the rating. The object would move down the scale toward normalcy. On the other hand, if those measurements prove inconsistent with natural explanations, if the data shows behavior that cannot be accounted for by known physics acting on known materials, then the rating goes up. And here is the threshold that matters. Level 10 on the Loeb scale is not awarded for anomalous behavior alone. It requires evidence of new objects near Earth or Mars that are related to 3I Atlas. In other words, if this thing released something, if smaller objects separated from the main body and headed toward the inner planets, that would elevate the rating to maximum. That would change everything. So far there is no public evidence of such objects. NASA has not reported detecting fragments or probes. No observatory has announced the discovery of related bodies. But Loeb has recommended that NASA specifically search for such evidence. He has urged them to check whether any new objects have been detected that might be associated with 3i Atlas. The fact that he felt the need to make this recommendation publicly suggests he takes the possibility seriously enough to want it formally investigated. As we stand now, 3i Atlas is the most anomalous object ever detected entering our solar system. It exceeds the strangeness of Oumuamua, which had its own set of unexplained features. It exceeds Borisov, which behaved more like a conventional comet but still raised questions about interstellar chemistry. 3i Atlas is in a category by itself, and the window for gathering the data that might explain it is closing rapidly. 17 days until closest approach to Earth. After that, the object recedes into interstellar space forever. Whatever 3i Atlas is, whatever secrets it carries, we have a brief moment to learn what we can before it disappears into the void from which it came. And that leads us to ask what happens next. How will scientists evaluate this object? What frameworks exist for making judgments about anomalous phenomena? The lobe scale is one such framework, controversial but structured. Understanding how it works and why it matters for 3i Atlas is where we go next. The lobe scale threshold. In the history of science, we have never had a formal system for classifying how strange an object is. We have taxonomies for stars, for galaxies, for chemical compounds, for biological organisms. We can categorize almost anything in the natural world based on its properties and behavior. But anomalies have always been handled informally. Something is either explained or unexplained, normal or weird. There was no scale, no spectrum, no structured way to say this object is strange, but this other object is stranger. Avi Loeb changed that. He created the Loeb scale specifically to address the problem of interstellar objects and the question of whether any of them might be artificial. The scale runs from 0 to 10. 0 means the object is completely normal, behaving exactly as we would expect a natural body to behave given its composition and environment. 10 means the object is confirmed artificial technology, manufactured by an intelligent civilization somewhere in the universe. Everything in between represents degrees of anomaly and uncertainty. Let me walk you through the levels because understanding them illuminates where 3i Atlas sits and what would need to change to move it up or down. Levels 0 through 2 represent natural objects with typical or slightly unusual behaviour. A comet that looks like a comet, acts like a comet, and matches our models for cometary physics would score in this range. Minor deviations from expectation, things that make scientists say, that is interesting, might push an object to level 2. But nothing at these levels challenges our fundamental understanding. Level 3 marks the boundary where anomalies become significant. An object at level 3 shows behaviour or properties that cannot be easily explained by conventional models. There might be multiple unusual features that together create a puzzle. Scientists would be actively debating what is going on, proposing alternative theories, disagreeing about interpretations. 3i Atlas was probably at level 3 early in its observation, when only a few anomalies had been documented. Level 4 is where 3i Atlas currently sits. This level indicates increasingly anomalous characteristics. The object is doing things that strain natural explanations without definitively ruling them out. Multiple independent anomalies have accumulated. The probability of all these features appearing together by chance is becoming uncomfortably low. At level 4, the scientific community should be paying serious attention, dedicating resources to observation and analysis, keeping open minds about various possibilities. Level 5 represents a threshold. At this level, the object becomes a suspected passive technology. The anomalies are so pronounced, so difficult to reconcile with natural processes, that artificial origin enters the realm of serious consideration. Not confirmed, not even probable, but possible in a way that cannot be dismissed. An object at level 5 would warrant dedicated search efforts for technological signatures, for radio emissions, for evidence of deliberate design or function. Levels 6 through 9 represent increasing confidence in artificial origin based on accumulating evidence. By level 9, the case for technology would be overwhelming even if direct confirmation remained elusive. These levels have never been assigned to any known object. Level 10 requires confirmation. This would mean either detecting a clearly artificial signal from the object, identifying manufactured components or structures, or, as Loeb has specified, discovering related objects that have separated from the main body and moved toward Earth or Mars. At level 10, the debate would be over. We would know. The question hanging over 3i Atlas right now is whether it should be elevated from level 4 to level 5. The past week has seen significant discussion about this in astronomical circles, much of it happening outside the mainstream journals in forums, social media threads, and private conversations among researchers. The anomalies are compounding. Each new observation seems to add something else to the list, and the distance to closest approach shrinks every day, intensifying the sense that a judgment must be rendered soon. What would it take to move to level 5? Loeb has been specific. If the measured speed, composition, and mass flux of the jets prove inconsistent with sublimation of volatiles from ice pockets on a natural comet surface, the rating would increase. In other words, if we can show that the physics of natural outgassing cannot explain what we're seeing, then natural explanations lose ground, and the possibility of something else gains it. The data to make that determination is coming. The James Webb Space Telescope will observe 3i Atlas in December, around its closest approach. Webb's spectroscopic capabilities can measure the composition and velocity of the outflowing material with unprecedented precision. If the gas is moving faster than thermal sublimation can explain, that is a problem for natural models. If the composition includes elements or compounds that should not be present in cometary outgassing, that is another problem. If the mass flux requires more energy than the Sun is providing at that distance, natural explanations start to fail. But there is another pathway to level 5 that does not require proving natural explanations wrong. It requires finding something additional. If observations reveal structure within the object that looks designed rather than natural, the rating would jump. If the jets show modulation, patterns that resemble signalling rather than random outgassing, the rating would jump. If, as Loeb has repeatedly suggested, smaller objects are detected separating from 3i Atlas and heading toward the inner planets, the rating would not just jump to 5, it would potentially go all the way to 10. The search for such objects is ongoing, though it is not being publicised. Loeb has called on NASA to specifically look for fragments or companion bodies associated with 3i Atlas. He has suggested that Mars rovers and orbiters might detect something arriving in their vicinity, given how close 3i Atlas passed to the red planet in early October. He has proposed that Earth-based surveys should be scanning for small objects on trajectories consistent with release from 3i Atlas. So far, nothing has been announced, but absence of announcement is not the same as absence of detection. Government agencies operate on their own timelines. Data processing takes time, analysis takes time. If something were found, the implications would be so significant that careful verification would be required before any public statement. We might not hear about it until long after the fact, if we hear about it at all. This is where things get uncomfortable for those of us watching from the outside. We are dependent on institutions for information. NASA controls the major space telescopes. Government agencies control the surveys. Professional astronomers have access to data that amateur observers cannot obtain. If there is something extraordinary about 3i Atlas, our ability to learn about it depends entirely on the willingness of these gatekeepers to share what they find. Loeb has been outspoken about this tension. He has criticised what he sees as a tendency in the scientific establishment to prematurely close questions, to declare objects normal before all the data is in, to dismiss anomalies rather than investigate them. His willingness to openly discuss the possibility that 3i Atlas might be artificial has made him controversial. Many of his colleagues think he is irresponsible for fueling public speculation. He thinks they are irresponsible for not taking the evidence seriously. The truth is probably somewhere in between. Most interstellar objects are almost certainly natural. The universe is vast and old, filled with debris from planetary formation around countless stars. The fact that some of that debris occasionally passes through our solar system is not surprising. Most of it will be unremarkable ice and rock, differing from our own comets only in the details of composition reflecting different stellar origins. But most is not all. And the history of science is filled with examples of anomalies that turned out to be real discoveries. Pulsars were initially dismissed as instrumentation errors until someone took them seriously. Exoplanets were considered unlikely until better detection methods proved they were everywhere. Continental drift was ridiculed for decades before plate tectonics became accepted fact. The scientific establishment has a tendency to resist paradigm shifts, to defend existing models against contradictory evidence, to demand extraordinary proof for extraordinary claims. That demand is not wrong. Extraordinary claims do require extraordinary evidence. but the demand can become a barrier when it is applied unevenly, when natural explanations are accepted with minimal scrutiny, while alternative hypotheses are held to impossible standards. The question should not be, is this object definitely artificial? The question should be, have we gathered enough evidence to know what it is? For 3I Atlas, we have not. Not yet. The data from perihelion is still being processed. The December observations have not happened yet. The analysis of composition, velocity and mass flux that would distinguish natural from anomalous behaviour is still ongoing. The lobe scale rating of 4 is appropriate for where we are right now, acknowledging significant anomalies while awaiting more information. But the pressure to move that rating is building. Every new image that shows the antitail still present, every measurement that shows jets still collimated, every calculation that shows mass loss still exceeding easy explanation, adds weight to the argument that 3I Atlas is more than a comet. Level 5 is not a determination of artificial origin. It is simply an acknowledgement that natural explanations are struggling. Whether the scientific community will make that acknowledgement remains to be seen. What we can say with confidence is that the next 17 days represent our best and possibly only opportunity to gather the evidence needed for judgment. December 19th is coming, and with it, either answers or the permanent frustration of unanswered questions as 3I Atlas disappears into the interstellar void. The countdown to that date, and what we might learn in the brief window remaining, is where we turn next. December 19. Countdown mark the date. December 19th, 2025. 17 days from now. That is when 3I Atlas reaches its closest approach to Earth, passing at a distance of approximately 269 million kilometres, about 1.8 astronomical units from our planet. After that point, the object begins its long journey outward, accelerating away from the Sun, eventually leaving our solar system forever. We will never see it again. Whatever it is, whatever secrets it carries, whatever answers it might provide to the questions that have captivated astronomers for 5 months, we have 17 days to learn them. Let me put that distance in perspective. 269 million kilometres sounds enormous, and it is. It is nearly twice the distance from Earth to the Sun, but in the context of astronomical observation, it is close. Close enough that ground-based telescopes with sufficient aperture can resolve details in the Comet and jets. Close enough that the Hubble Space Telescope can capture high-resolution images showing structure we could not see when the object was more distant. Close enough that the James Webb Space Telescope can perform spectroscopic analysis with precision sufficient to determine exact compositions and velocities of the outflowing material. This is our window. This brief period in December when 3I Atlas is as close as it will ever get, and as well positioned for observation as circumstances allow. The telescopes are scheduling time, the observation campaigns are being planned. For perhaps 2 to 3 weeks centred on that December 19th date, we will have optimal conditions to study this visitor before it fades into the darkness. What specifically will scientists be looking for? Several things. First, composition. The James Webb Space Telescope can identify specific molecules in the outgassing from 3I Atlas based on their spectroscopic signatures. We already know the gross composition from earlier Webb observations, carbon dioxide dominant with smaller amounts of carbon monoxide and water. But December observations can refine those measurements and potentially identify trace compounds that were below detection thresholds earlier. If 3I Atlas contains molecules that do not fit natural cometary chemistry, December is when we will find them. Second, velocity. The speed at which gas and dust leave the nucleus tells us about the mechanism driving the outflow. Thermal sublimation produces material moving at characteristic velocities determined by temperature and molecular mass. If the jets from 3I Atlas are moving faster than thermal processes can explain, that points to additional energy sources or different physical mechanisms. Spectroscopy can measure these velocities through Doppler shifts in the emission lines. Third, structure. High-resolution imaging in December can reveal details in the jets and coma that were not visible earlier. The anti-tail should be clearly observable. The collimation of the jets can be measured precisely. If there are variations in brightness or structure that correlate with the 16-hour rotation period, those patterns will be most evident when the object is closest. Any asymmetries, any unexpected features, any hints of design or organisation will be most visible now. Fourth, and perhaps most importantly, the search for associated objects. Loeb has recommended that NASA specifically look for smaller bodies that might have separated from 3I Atlas. If this object released probes, if it fragmented in ways that sent material toward the inner planets, December observations might detect those secondary objects. This is the pathway to level 10 on the Loeb scale. This is what would transform speculation into confirmation. The amateur astronomy community is mobilizing as well. Images of 3I Atlas have been appearing daily from skilled astrophotographers around the world. Tirasak Thalawang in Thailand has been producing remarkable images with a modest 0.26 meter telescope. Mitsunori Tsumura in Japan captured stunning photographs showing the dual tail and anti-tail structure. Elena Walter in Chile, Peter Carson Lee in Spain, Frank Niebling and Michael Buchner in Europe all have contributed observations that complement the professional data. These amateur observations matter. They provide temporal coverage that professional telescopes cannot match. Large observatories have limited time available, shared among many competing scientific programs. An amateur with a dedicated telescope can image 3I Atlas every clear night, building a time series that reveals changes and variations the big telescopes might miss. The heartbeat pattern in the brightness variations was initially detected through such persistent observation. The continued presence of the anti-tail after perihelion was confirmed through amateur images before professional facilities caught up. If something dramatic happens in the next 17 days, if 3I Atlas shows unexpected behaviour or reveals something truly extraordinary, the amateur network will likely see it first. They are watching every night. They are sharing images in real time. They are collectively building a record of this visitation that future scientists will study for decades. But there is a shadow over these final weeks of observation. The government shutdown that occurred in October delayed the release of crucial data from NASA missions. Images taken by the HIRAS camera on the Mars Reconnaissance Orbiter on October 2nd and 3rd, when 3I Atlas passed within 29 million kilometres of Mars, were held for over 40 days. Those images should have provided our best view of the object's structure during its most active period near perihelion. Instead, they sat in a queue while bureaucratic processes played out. When NASA finally held its press conference on November 19th, the released data was limited. A smeared image showing a fuzzy blob degraded by spacecraft jitter and motion during observation. Nothing that definitively answered the pressing questions. Nothing that moved the needle on whether 3I Atlas is natural or anomalous. Scientists expressed frustration. Loeb wrote pointedly about the delay, asking why the most significant interstellar object ever observed received such treatment. Will December be different? The government shutdown has ended. NASA has promised more observations and more data releases. The Webb telescope is scheduled to observe. Hubble will observe. Ground telescopes, including the Keck Observatory in Hawaii, will train their instruments on the approaching object. In principle, we should get everything we need. In practice, institutional dynamics may intervene. If the data shows something ordinary, a natural comet behaving as comets do, release will be straightforward. Scientists will write papers confirming that 3I Atlas, despite its unusual features, is ultimately explicable through known physics. The mainstream narrative will be reinforced. Case closed. But if the data shows something extraordinary, something that challenges natural explanations, release becomes complicated. Verification would be essential. Peer review would be demanded. Government agencies would likely want to control the message. The implications of confirming an artificial object in our solar system would be so significant that no institution would want to announce prematurely. We might wait months or years for definitive data, even if it is collected in the next 17 days. This is why the amateur community matters so much. They operate outside institutional constraints. Their images appear on social media within hours of capture. They cannot be delayed by bureaucracy or controlled by messaging concerns. If 3I Atlas does something spectacular during its close approach, the amateur network will document it in real time for the world to see. The scientific questions are clear. The observation plans are in place. The telescopes are ready. What remains unknown is what 3I Atlas will reveal, and whether the institutions tasked with studying it will share what they learn in a timely and transparent manner. 17 days, 408 hours, 24,480 minutes. That is how long we have before our best observing window closes. Some of those minutes will bring clouds that block telescopes. Some will bring technical failures that lose data. Some will bring bureaucratic decisions that delay releases. But some will bring new images, new spectra, new measurements that add to our understanding. By early January, the window will be closing. 3i Atlas will be receding, growing fainter, becoming harder to observe with precision. By March, it will reach its closest approach to Jupiter, possibly detectable by the Juno spacecraft, but primarily of interest for gravitational studies rather than compositional analysis. By the late 2020s, it will have crossed beyond the orbits of all the major planets. By the 2030s, it will be a faint point requiring the largest telescopes to detect at all. And then, nothing. Gone forever into the interstellar medium from which it came. Whatever 3i Atlas is, we have this moment and no other. This December and no future December. This chance and no second chance. The universe sent us a visitor from another star, and we have 17 days to understand what came calling. That urgency permeates every aspect of the current discussion. It drives Loeb's persistent advocacy for open-minded investigation. It fuels the amateur observers who image through fatigue and weather. It underlies the tension between those who want quick answers and those who demand careful verification. We are all operating under the same deadline, the same countdown, the same awareness that this opportunity is finite. But there is one anomaly we have not yet explored in depth, one feature of 3i Atlas that deserves its own focused attention. The nickel problem. The unusual composition that spectroscopy has revealed. Understanding what that composition means and why it matters for the question of origins is where we turn next. The nickel anomaly. When a comet approaches the Sun, it heats up. The ices that make up its nucleus begin to sublimate, transitioning directly from solid to gas. That gas carries with it dust and debris from the comet's interior, material that has been locked in frozen storage since the object formed billions of years ago. By analysing the composition of that outgassing, scientists can determine what the comet is made of. It is like performing an autopsy on a body that has been cryogenically preserved since the dawn of its stellar system. The composition tells us where it came from, what conditions existed when it formed, and what raw materials were available in its birth environment. The spectroscopic analysis of 3i Atlas has revealed something unexpected. Nickel, lots of it, and not nearly as much iron as should, accompany it. In our solar system, nickel and iron are closely associated. They form together in stellar nucleosynthesis, the process by which stars fuse lighter elements into heavier ones in their cores. When massive stars explode as supernova, they scatter both elements into the surrounding gas and dust that will eventually form new stars and planets. The ratio of nickel to iron in our solar system's primordial material is well established. It shows up in meteorites, in asteroids, in the dust of comets. When you find nickel, you expect to find iron in predictable proportions. 3i Atlas does not follow that pattern. The nickel emissions detected in its outgassing are dominant, while iron signatures are anomalously low or absent. This is not how solar system comets behave. This is not how we would expect any natural icy body to behave, regardless of its origin. The nickel to iron ratio is telling us something about where this object came from and what processes shaped its composition. Several explanations have been proposed. The first is that 3i Atlas formed in a stellar environment with fundamentally different nucleosynthetic history than our Sun. Different stars produce different element ratios depending on their mass, age, and the specific nuclear reactions occurring in their cores. A star with unusual metallicity, orbiting in a region of the galaxy with different chemical enrichment history, might produce planetary materials with different nickel to iron ratios. 3i Atlas could be a messenger from such an alien chemistry. But this explanation has problems. The difference would need to be extreme to produce the ratios we are observing, and 3i Atlas shows other compositional features, the carbon dioxide and carbon monoxide we have discussed, that are not particularly exotic. If it came from a truly alien chemical environment, we might expect more elements to show unusual abundances, not just nickel. The second explanation involves processing rather than origin. Perhaps 3i Atlas started with normal nickel to iron ratios, but experienced conditions during its interstellar journey that selectively removed or altered the iron. Cosmic ray bombardment over billions of years could potentially drive chemical changes in surface materials. Heating events during close passes to other stars might have caused differential sublimation. Some process might have preferentially stripped iron while leaving nickel intact. This explanation is more plausible but still requires specific conditions. Iron and nickel have similar chemical properties in many contexts. Finding a natural process that would dramatically separate them is not straightforward, and the timescales involved, potentially billions of years of interstellar travel, make it difficult to test such hypotheses. The third explanation connects to the cryovolcanism we discussed earlier. The Spanish research team led by Trigo Rodriguez proposed that the unusual emissions result from chemical reactions occurring as 3I Atlas heats up. When carbon dioxide ice sublimates, it enables an oxidizing liquid to flow into the comet's interior and react with metallic grains. Iron sulfides and nickel compounds would respond differently to this oxidation. If the reactions preferentially release nickel while retaining iron in non-volatile forms, the observed emissions would show nickel dominance even if the bulk composition is more balanced. This is perhaps the most elegant natural explanation. It does not require exotic origin chemistry or unlikely processing history. It simply requires specific mineralogy and thermal conditions that favour nickel release over iron release during the current heating event. The comet could have normal nickel to iron ratios in its interior, while showing nickel-dominant emissions in its current outgassing. But even this explanation raises questions. The cryovolcanic model suggests 3I Atlas has internal structure, pockets of different materials that respond differently to heating. It suggests organised activity driven by chemical reactions rather than simple thermal sublimation. It adds complexity to our picture of this object, making it less like a simple dirty snowball and more like a geologically active body with differentiated composition. And here is where the speculation becomes uncomfortable. If you wanted to design an object that would appear natural while passing through a foreign solar system, you might give it an icy exterior that produces familiar cometary signatures when heated. But the interior could be something else entirely. The unusual nickel emissions might be a side effect of internal structure that serves a purpose other than passive response to solar heating. The cryovolcanism might be a symptom of activity that is not purely geological. I want to be clear that this is speculation. There is no evidence that 3I Atlas is artificial. The nickel anomaly has natural explanations that may well prove correct. But the pattern keeps repeating. Every time we look closely at this object, we find something unexpected. Every time we think we understand it, a new anomaly emerges. The nickel is just the latest entry on a list that grows longer with each observation. The spectroscopic data also revealed that 3I Atlas shares characteristics with a specific class of meteorites called carbonaceous chondrites. These are primitive, carbon-rich space rocks that represent some of the oldest and least altered material in our solar system. They are believed to contain samples of the primordial solar nebula, the cloud of gas and dust from which the sun and planets formed. Finding similarity between an interstellar comet and our most primitive meteorites is significant. It suggests that whatever star system 3I Atlas came from, it may have had similar starting conditions to our own. The building blocks of rocky and icy bodies, the carbon compounds and metallic grains and volatile ices might be universal across stellar systems. The differences in nickel to iron ratios could represent variations on a common theme rather than completely alien chemistry. This has implications beyond 3I Atlas. If interstellar objects broadly resemble our solar system's primitive materials, it suggests a kind of cosmic uniformity. The galaxy might be filled with similar raw materials, forming similar objects around similar stars, producing life-bearing worlds that share fundamental chemistry. The panspermia hypothesis, the idea that life or its precursors might spread between stars through cometry and asteroid impacts, becomes more plausible if the delivery vehicles share common compositions. But the nickel anomaly also implies differences. Whatever processes formed 3I Atlas, they were not identical to what formed our solar system's comets. The object is similar but not the same, familiar but foreign, a cousin from a distant branch of the stellar family tree. Understanding exactly what makes it different, and what those differences mean, requires more data than we currently have. The December observation should help. Webb telescope spectroscopy can refine the composition measurements, identifying trace elements and isotope ratios that provide additional constraints on origin. If 3I Atlas shows isotopic signatures inconsistent with solar system materials, that would strengthen the case for exotic origin. If the signatures are consistent with our local neighbourhood of the galaxy, that would support the cryovolcanic processing explanation. Either way, the nickel anomaly adds to the puzzle. It is one more piece that does not quite fit the picture of a simple natural comet. One more feature that requires explanation beyond the obvious. One more entry on Loeb's list of anomalies that together paint a portrait of an object unlike anything we have studied before. The composition data also connects to another unresolved question: the mass. If 3I Atlas has the dense, metallic, rich interior suggested by the nickel emissions, it might explain how an object of its size maintains the structural integrity we have observed. A nickel-iron core, or distributed metallic grains throughout its bulk, would provide strength that pure ice would lack. It would explain how the object survived perihelion without fragmenting. It would explain the non-gravitational acceleration that implies massive outgassing without structural failure. But a metallic core also makes 3I Atlas heavier than a pure ice comet. The mass estimate of over 33 billion tons already places it far beyond typical cometary objects. If that mass includes significant metal content, the density would be higher than ice alone can achieve. We would be looking at something more substantial than a dirty snowball. Something more structured, something with architecture. I keep returning to that word: structure, organisation, architecture. These are not terms we typically apply to comets. Comets are supposed to be loose aggregates of primordial material, rubble piles held together by weak gravity and surface cohesion. They fragment easily. They crumble under thermal stress. They are the solar system's remnant debris, leftovers from planetary formation. 3I Atlas does not behave like debris. It behaves like a coherent object with internal organisation. Its jets are structured. Its emissions are organised. Its composition is differentiated. Its survival through perihelion demonstrates integrity. Everything about it suggests something more substantial than the typical comet model allows. What that something is remains the central question. The nickel anomaly does not answer it, but it narrows the possibilities. It rules out the simplest explanations and forces us toward more complex models. Models involving internal structure, chemical processing, organised activity. Models that inch closer to the uncomfortable territory where natural and artificial become harder to distinguish. The December observations may resolve this tension, or they may deepen it. But the data is coming, and with it, perhaps, some clarity on what exactly is producing the strange chemical signatures in the outgassing of our interstellar visitor. And speaking of unanswered questions, there is another source of tension that we need to address directly. The institutional response to 3I Atlas, and specifically what NASA has and has not revealed about this object, is itself becoming a story. That institutional dynamic, and why it matters, is where we go next. What NASA will not say. On November 19th, NASA held a press conference about 3I Atlas. The event was anticipated. For weeks, the scientific community and the interested public had been waiting for official data from the agency's fleet of spacecraft that had observed the interstellar visitor during its October perihelion passage. The Mars Reconnaissance Orbiter had imaged it. The Lucy mission had tracked it. Multiple assets had gathered data during the critical period when 3I Atlas was hidden from Earth-based telescopes behind the Sun. Now, finally, that data would be shared. The press conference lasted about an hour. NASA scientists presented images, they discussed observations, they answered questions, and when it was over, the most common reaction from those who had been following the story closely was disappointment. The images were limited. The high-rise camera on the Mars orbiter had captured 3I Atlas from a distance of about 19 million miles, achieving a spatial resolution of 30 kilometers per pixel. That sounds impressive until you realize what it means in practice. At that resolution, an object the size of 3I Atlas, estimated at somewhere between 440 meters and 5.6 kilometers across, appears as a smeared blob spanning just a few pixels. The spacecraft jitter during observation further degraded the images. What we got was a fuzzy white dot, indistinct and uninformative. NASA's spokesman Tom Statler opened the press conference with a definitive statement. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. He addressed the speculation that had been swirling online, the questions about artificial origin, the suggestions that 3I Atlas might be something other than a natural object. The agency's position was clear. Nothing to see here. Move along. But here is what struck many observers as strange. The definitiveness of that statement did not match the limitations of the data being presented. The images were inconclusive. They showed a bright object with some extension, consistent with a coma, but revealed nothing about structure, composition, or the specific anomalies that had been documented by other observers. The spectroscopic data, the measurements that would definitively characterize the jets and their properties, were not included. The detailed analysis that might confirm or refute the unusual features, none of that was shared. Avi Loeb wrote about the press conference immediately afterward. He noted that he had predicted exactly what would happen. NASA would repeat the official mantra that 3I Atlas is a natural comet. They would be unable to process the data in time because of the government shutdown. They would provide limited information that settles nothing while appearing to close the discussion. He was right. That is exactly what happened. Now, I want to be fair to NASA. Government agencies operate under constraints that outside observers do not always appreciate. The shutdown did delay data processing. Limited resources did force prioritization. The images that were released may genuinely represent the best that was available at the time, and caution about extraordinary claims is not unreasonable. An agency that rushed to announce an artificial object, only to be proven wrong, would face severe credibility damage. But caution cuts both ways. An agency that dismisses anomalies without thorough investigation, that declares natural origin before all data is analysed, that fails to take seriously the observations that do not fit the preferred narrative, also damages its credibility. And for many watching the 3I Atlas story unfold, NASA's response has seemed more like dismissal than investigation. Consider the contrast with how Loeb and the amateur astronomy community have approached this object. Every anomaly documented, every unusual feature noted, every observation shared publicly in near real time. The Medium blog posts appear daily, sometimes multiple times per day, analysing new data as it becomes available. The amateur images hit social media within hours of capture. The discussion is open, iterative, self-correcting. NASA's approach has been the opposite. Limited releases, long delays, definitive statements that outrun the supporting evidence. A resistance to engaging with the specific anomalies that make 3I Atlas unusual. When Loeb documents 12 mysteries, NASA's response is not to address them one by one. It is to wave them away with the assertion that this is a comet. The tension came to a head around the high-rise images. Those images were taken on October 2nd and 3rd, when 3I Atlas passed within 29 million kilometres of Mars. That was the closest any spacecraft would come to the object during its entire passage through the inner solar system. The images should have been priority data, processed and released as quickly as possible. Instead, they sat for over 40 days, held up by the government shutdown according to NASA's explanation. Congresswoman Anna Paulina Luna got involved, tweeting about the delayed release and demanding transparency. Loeb submitted a formal letter to NASA requesting the images. The pressure eventually produced results, and the images were included in the November 19th press conference. But what was released fell far short of what many had hoped for. Smeared, indistinct, uninformative. Was this really the best the high-rise camera could do? The same camera that has captured stunning high-resolution images of Mars surface features, of Phobos and Deimos, of various small bodies passing near the red planet. Either 3I Atlas is intrinsically featureless at this resolution, which would be surprising for an object with the dramatic jet structures seen in Earth-based images, or the data processing left something to be desired. Questions like this fuel suspicion. They create the impression that information is being managed rather than shared. They make people wonder what else might exist in the data that has not been released. The situation is compounded by the timing of the shutdown itself. 3I Atlas reached perihelion on October 29th, right in the middle of the government closure. The most critical period of observation, when the object was most active and most illuminated by solar heating, occurred while NASA's data pipelines were frozen. Coincidence? Almost certainly. The shutdown was driven by political dynamics that have nothing to do with astronomy. But the effect was to create a gap in coverage precisely when coverage mattered most. And this is where conspiracy theories take root. Not because the theories are likely true, but because institutional behaviour creates the space for them. When an agency dismisses questions rather than answering them, when data is delayed rather than released, when definitive statements are made without supporting evidence, people start to wonder, what is being hidden? What do they know that they are not telling us? Loeb has walked a careful line on this. He does not claim NASA is engaged in a cover-up. He does not accuse specific individuals of dishonesty, but he has been pointed in his criticism of institutional culture, of the tendency to assume conclusions rather than investigate evidence, of the arrogance of expertise that dismisses anomalies without explanation. His position is simple. We do not know what 3I Atlas is. The evidence is genuinely ambiguous. The anomalies are real and documented. The proper scientific response is to gather more data, analyse it carefully, and remain open to multiple possibilities until the data forces a conclusion. NASA's response, in his view, has been to skip straight to the conclusion while ignoring the data that does not fit. Whether that criticism is fair depends on information we do not have. Perhaps NASA's internal analyses have addressed each anomaly and found natural explanations. Perhaps the unreleased data is conclusive in ways the public releases are not. Perhaps the definitiveness of the statements reflects genuine scientific confidence rather than institutional defensiveness. We cannot know without access to the full data and the complete analysis. What we can say is that the current situation is unsatisfying. The most anomalous interstellar object ever observed is being discussed in two completely different registers. In the mainstream scientific establishment, it is a comet, end of story. In the open discussion happening on social media and in independent analysis, it is a profound mystery with multiple possible explanations. These two conversations rarely engage with each other. They exist in parallel, each confident in its own framework, neither convincing the other. The December observations offer a chance to bridge this gap. If Webb and Hubble and the ground-based telescopes produce data that is released promptly and analysed transparently, if the specific anomalies are addressed directly rather than waved away, if the scientific community engages with the unusual features rather than dismissing them, then the discussion might converge toward consensus. But if the pattern continues, if NASA maintains its position while ignoring the documented anomalies, if data is delayed or limited or presented in ways that prevent independent verification, the gap will only widen. The opportunity to study 3I Atlas will pass. The object will disappear into interstellar space, and we will be left with unanswered questions and lingering suspicions about what we might have learned if institutions had approached this visitor with more openness. That would be a tragedy. Not because 3I Atlas is necessarily artificial. Probably it is not. But because science works best when it is transparent, when data is shared, when anomalies are investigated rather than dismissed. The universe sends us mysteries. Our job is to solve them. And right now, for this particular mystery, the institutions tasked with solving it seem more interested in declaring it solved than in actually doing the work. The clock is ticking. 17 days until closest approach. The December observations will happen. Data will be collected. And then we will see whether the scientific establishment rises to the occasion or continues to disappoint. In the meantime, the analysis continues elsewhere, in blog posts and amateur images and independent calculations. The truth is out there, somewhere in the light reflecting off that distant visitor. The question is whether we will be allowed to see it, and that brings us to another piece of the puzzle, one that connects 3I Atlas to our own solar system in unexpected ways, the trans-Neptunian connection. The similarity between this interstellar visitor and objects orbiting in the cold outer reaches of our own cosmic neighbourhood. Understanding that connection, and what it tells us about the origin of 3I Atlas, is where we turn next. Trans-Neptunian twin from the stars beyond the orbit of Neptune, in the cold, dark reaches of our solar system, there exists a population of objects that most people have never heard of. Trans-Neptunian objects, they are called. Dwarf planets like Pluto and Eris, smaller bodies like Sedna and Makemake, and countless thousands of unnamed rocks and ice balls that orbit the Sun at distances so great that our star appears as little more than a bright point in their skies. These objects are remnants from the formation of the solar system, preserved in deep freeze for 4.5 billion years, barely touched by the Sun's warmth. When 3I Atlas entered our inner solar system and began heating up, it started behaving in ways that immediately reminded scientists of these distant cousins. The cryovolcanism we discussed. those organised spiral jets of erupting ice, is exactly what we would expect from a trans-Neptunian object if one were somehow brought close to the Sun. The composition, rich in carbon compounds and metallic grains, matches the signatures we detect from the outer solar system. The structural integrity, the ability to survive intense heating without fragmenting, suggests the kind of dense, coherent body that forms in the cold outer regions of planetary systems. The Spanish research team led by Josep Trigo Rodriguez made this connection explicit in their recent preprint. They compared the spectroscopic signature of 3I Atlas to carbonaceous chondrites, those primitive meteorites that represent some of the oldest material in our solar system. Among their samples was one believed to contain fragments of a trans-Neptunian object. The match was remarkably close. Despite originating around another star, 3I Atlas shares fundamental characteristics with objects from the most distant parts of our own cosmic neighbourhood. Think about what this means for a moment. 3I Atlas has travelled through interstellar space for billions of years. It formed around a star that may no longer exist, in a planetary system whose history we will never know. It crossed the vast gulfs between stellar systems, enduring cosmic ray bombardment and the absolute cold of the interstellar medium. And, when it finally arrived here, when it began responding to our Sun's radiation, it behaved like something we would recognise from our own outer solar system. The implication is profound. The processes that form icy bodies in the outer reaches of planetary systems may be universal. The same chemistry, the same structures, the same behaviour might arise around stars throughout the galaxy. If 3I Atlas is representative, and we now have a sample size of 3 interstellar objects which is not much to generalise from, then the universe may be filled with objects compositionally similar to our trans-Neptunian population. The raw materials of the cosmos, processed in similar ways around similar stars, produce similar results. This has implications for questions far beyond 3I Atlas itself. If interstellar objects carry materials similar to our own primitive solar system bodies, they could potentially deliver the building blocks of life to planets throughout the galaxy. Carbonaceous chondrites, the meteorites that 3I Atlas resembles, are believed to have played a role in delivering organic compounds and water to early Earth. They may have seeded our planet with the chemical precursors necessary for life to emerge. If objects like 3I Atlas occasionally impact planets in other stellar systems, they might perform the same function elsewhere. The panspermia hypothesis, the idea that life or its precursors might spread between stars through natural mechanisms, gains plausibility from this connection. You do not need exotic chemistry or improbable circumstances. You just need the same processes that operated in our solar system operating in others, producing objects that occasionally escape their home systems and wander between the stars. Some of those wanderers might carry organic complexity. Some might land on worlds where conditions favour further chemical evolution. The galaxy becomes a more connected place than we might have imagined. But here is where the trans-Neptunian connection also raises questions. Our trans-Neptunian objects have been in cold storage since the solar system formed. They have not been heated by close solar approaches. They have not undergone the thermal processing that 3I Atlas has experienced. We know what they look like in their frozen state, but we have limited data on how they would behave if brought into the inner solar system. 3I Atlas is providing that data. It is showing us what a trans-Neptunian type object looks like when heated, when activated, when its volatiles begin to sublimate, and its internal processes come to life. The cryovolcanism, the organised jets, the strange chemical signatures, all of these might be perfectly normal for this class of object under these conditions. We simply have not had the opportunity to observe it before. This is valuable science regardless of any speculation about artificial origin. Understanding how these primitive icy bodies respond to stellar heating tells us about the physics and chemistry of planetary formation. It constrains models of how water and organic compounds are distributed through planetary systems. It helps us understand what happens when comets from the Oort cloud, our own reservoir of distant icy objects, occasionally fall into the inner solar system. But the trans-Neptunian connection also highlights what remains anomalous about 3I Atlas. Trans-Neptunian objects, when perturbed into the inner solar system, typically fragment. The thermal stresses of approaching the Sun, combined with the relatively weak gravity and loose structure of these bodies, leads to breakup. We have observed this process with comets from our own Oort cloud. They crumble, they shatter, they leave trails of debris. 3I Atlas did not fragment. It survived perihelion as a single body. Despite experiencing solar heating intense enough to drive massive outgassing, despite losing potentially billions of tons of material through its jets, the object remains structurally intact. This is unusual for a trans-Neptunian-type body. It suggests either unusual composition, unusual structure, or unusual origin. The nickel enrichment we discussed might be part of the explanation. If 3I Atlas has a higher metal content than typical trans-Neptunian objects, that metal would provide structural reinforcement. A nickel-iron-rich interior would hold together where pure ice would crumble. The object would be denser, stronger, more coherent than bodies composed primarily of volatiles. But this raises its own questions. How did a trans-Neptunian-type object acquire such significant metal content? Our understanding of how these bodies form suggests they should be ice-dominated with rocky and metallic components distributed throughout. A metal-rich core would require different formation conditions, perhaps closer to the host star or in a region with different abundance ratios. Alternatively, the metal enrichment could result from processing during interstellar transit. Billions of years of cosmic ray bombardment might alter surface and near-surface composition. Radioactive decay of trace elements might generate heat that causes internal differentiation. The object that arrived in our solar system might differ from the object that left its home system eons ago. These are testable hypotheses. The December observations can refine the composition measurements. They can constrain the density and structure through analysis of the jets and coma. They can help determine whether 3I Atlas is an unusually metal-rich trans-Neptunian-type object, a normal object that appears strange due to observational effects, or something else entirely. What seems increasingly clear is that 3I Atlas represents a bridge between the familiar and the foreign. It shows us characteristics we recognize from our own solar system, while exhibiting behaviors that push the boundaries of our models. It is neither completely alien nor completely familiar. It occupies an uncomfortable middle ground where easy categorization fails. This is precisely why it matters so much. 3I Atlas is teaching us something about the universe that we did not know before. Whether that something is about the diversity of natural objects, or about the possibility of artificial ones, whether it confirms our models or challenges them, whether it closes questions or opens new ones, we are learning. That is the value of anomalies. They show us where our understanding is incomplete. The trans-Neptunian twin from the stars has arrived. It has revealed characteristics both recognizable and strange, and now, as it approaches its closest point to Earth before departing forever, we have one final chance to understand what kind of twin it really is. Natural cousin or something else. Cosmic accident or cosmic intention. The answer, if we are lucky, lies in the data that December will bring, and that brings us to our final consideration, the verdict window, the brief period we have left to gather the evidence that might settle, once and for all, what 3I Atlas actually is. The stakes of that window, and what happens if we miss our chance, is where we conclude our investigation. The final verdict window. We have arrived at the crux of everything. The window. The brief, finite, irreplaceable opportunity to determine what 3I Atlas actually is before it disappears from our reach forever. 17 days until closest approach on December 19th, perhaps another 2 weeks of quality observation after that. And then the long fade into the outer solar system, the gradual dimming as distance increases and our telescopes lose their grip on this visitor. By January the window narrows, by February it is closing. By March, when the object reaches Jupiter's orbit, only the most powerful instruments will detect it at all. And then nothing. This is not hyperbole. This is physics. 3I Atlas is moving at roughly 30 kilometers per second away from the Sun. That velocity carries it farther from Earth with every passing moment. Distance increases. Signal strength decreases. Resolution degrades. The details we can distinguish today will be invisible tomorrow. The questions we can answer now become unanswerable soon. So what can still be determined in the time remaining? What evidence would settle the debate one way or another? For those who believe 3I Atlas is a natural comet, confirmation would come from December observations showing behaviour fully consistent with known physics. If the jets demonstrate velocities matching thermal sublimation models, if the composition shows nothing inconsistent with natural cometary chemistry, if the mass loss rates are explainable by solar heating of ice surfaces, if the structural integrity can be attributed to density and cohesion within established parameters, if every anomaly on Loeb's list can be addressed with specific natural mechanisms, Then the object is a comet, unusual but not unprecedented, and the case is closed. For those who entertain the possibility that 3I Atlas might be something else, the bar is higher. Confirmation of artificial origin would require positive evidence, not just failure of natural explanations. It would require detection of signals or structures or behaviours that have no natural interpretation. It would require, as Loeb has specified, evidence of related objects separating from the main body and heading toward the inner planets. It would require something definitive, not merely suggestive. The honest assessment is that December observations are more likely to favour the natural interpretation. The default assumption in science is natural causation. Extraordinary claims require extraordinary evidence. And while 3I Atlas has shown numerous anomalies, none of them individually or collectively rise to the level of proof for artificial origin. The most probable outcome is that careful analysis will find natural explanations for each unusual feature, and the object will be catalogued as an exotic but natural interstellar comet. But probability is not certainty, and the purpose of observation is to test hypotheses, not to confirm them. If we approach December with the assumption that we already know what 3I Atlas is, we risk missing evidence that might tell us otherwise. The proper scientific attitude is openness combined with rigour. Look for everything. Assume nothing. Let the data speak. What would that data look like if it spoke of something other than a comet? What would we see that would elevate 3I Atlas from level 4 to level 5 or beyond on the Loeb scale? The first thing would be jet velocities inconsistent with thermal processes. If gas is leaving the object faster than sublimation can drive it, something else is providing energy. That something could be internal heat from radioactive decay, which would be surprising but natural, or it could be something with no natural explanation. The second thing would be compositional signatures that cannot arise from known chemistry. If spectroscopy reveals compounds or element ratios that no natural process can produce, we face a choice. Either our understanding of chemistry is incomplete, or the object's chemistry is not natural. The third thing would be detection of structure in the jets or coma that shows evidence of design. Patterns that resemble information encoding. Regularities too precise for natural processes. Geometry that implies purpose. This is subjective and hard to define, but it is the kind of evidence that would change minds. The fourth thing, and the most definitive, would be detection of associated objects. Fragments moving independently, smaller bodies on trajectories that suggest release from the main object. Probes, if we are being explicit about the speculation. Loeb has urged NASA to look for exactly this. If something separated from 3I Atlas and headed toward Earth or Mars, we would know. That would be level 10. That would change everything. The probability of any of these is low, but low is not 0. And if we do not look, we cannot find. The December window is our chance to look with the best instruments available. Whether we find confirmation of natural origin or something more surprising depends on what is actually there. I want to pause here and address something directly. Over the 5 months since 3I Atlas was discovered, this object has become a kind of Rorschach test for people's attitudes toward science, toward institutions, toward the unknown. Some see a comet and nothing more, dismissing any speculation as unscientific fantasy. Others see evidence of extraterrestrial visitation, connecting dots that may or may not be connected, finding patterns that may or may not be real. Both groups are certain. Both groups are frustrated with the other. The truth is that we do not know. That is not a weakness. That is the starting point of all genuine inquiry. We do not know what 3I Atlas is. We have evidence that it is unusual. We have theories that might explain its unusual features. We have a closing window to gather more evidence, and we have the intellectual obligation to remain open to whatever that evidence shows. If 3I Atlas turns out to be a natural comet, that is still a remarkable discovery. The third interstellar object ever detected, the largest and most massive by far, a visitor that shows us what other stellar systems produce, that demonstrates the universality of certain physical and chemical processes, that provides a sample, however indirect, of material from another star. That alone justifies the attention. If 3I Atlas turns out to be something else, the implications are beyond calculation. First contact of a sort with evidence that we are not alone in the universe, confirmation that technology can cross interstellar distances, questions about intent, about origin, about what a visit means, changes to every assumption we hold about our place in the cosmos. The stakes are asymmetric. If it is a comet, we learn something interesting about comets. If it is not a comet, we learn something that rewrites the human story. This asymmetry is why some scientists are willing to entertain speculation that others find irresponsible. The downside of being wrong about natural origin is embarrassment. The downside of being wrong about artificial origin is missing the most important discovery in human history. 17 days. That is what remains. The telescopes will observe, the data will flow, the analysis will proceed. And somewhere in that flood of photons and spectra and measurements, the truth about 3I Atlas waits to be discovered. Or perhaps not discovered. Perhaps the data will be ambiguous. Perhaps the anomalies will persist without resolution. Perhaps 3I Atlas will leave our solar system, with its secrets intact, an enigma that we studied but never understood. That outcome is possible too. The universe is not obligated to answer our questions, but we are obligated to ask them. We are obligated to look, to measure, to analyze, to think. We are obligated to approach the unknown with humility and curiosity rather than certainty and dismissal. We are obligated to follow the evidence wherever it leads, even if that destination is uncomfortable. 3I Atlas is leaving. In weeks it will be gone. Whatever it is, whatever story it carries from the star system that birthed it, whatever message its anomalies might or might not convey, this is our only chance to read it. The window is closing. Let us not waste it. And with that, we arrive at the end of our investigation for today. We have travelled through the heartbeat in the void, the ice volcanoes erupting on an interstellar body, the anti-tail that defies our understanding of cometary physics, the 12 anomalies that compound into something greater than their parts. We have explored the lobe scale and its thresholds, the countdown to December 19th, the strange nickel signatures in the outgassing, the tension between open inquiry and institutional caution. We have traced the connection to trans-Neptunian objects in our own solar system and considered what that connection tells us about the universe's chemistry, and we have confronted the final verdict window, the brief remaining opportunity to learn what we can before this visitor disappears forever. The questions remain open. The data keeps coming. And out there, right now, moving at 30 kilometers per second toward the outer solar system, 3I Atlas continues its journey. Whatever it has captivated us for 5 months. Whatever it turns out to be, it has reminded us that the universe is vast, strange, and full of mysteries we have not yet solved. Thank you for joining me on this exploration. If you found value in this deep dive, if you appreciate the effort to synthesize the latest research and present it without the filters that mainstream coverage often applies, please consider liking this video and subscribing to the channel. Your support enables this work to continue, and share your thoughts in the comments. Do you think 3I Atlas is a natural comet? An anomalous object that defies easy categorization? Something else entirely? I read every comment and I am genuinely curious what you think. A quick note before we go. While we have done our best to present the science accurately and fairly, this content is for educational and entertainment purposes. The speculation about artificial origin represents a minority viewpoint in the scientific community. Most astronomers believe 3I Atlas is a natural object, and that assessment is based on decades of expertise in cometary physics. We present the alternative perspectives not because they are likely correct, but because they are part of the conversation, and because scientific progress often comes from entertaining unlikely possibilities. Wherever you are listening from, whatever time it is there, I hope you found something in this discussion that sparked your curiosity. The universe is under no obligation to make sense to us, but it rewards those who pay attention. 3I Atlas is paying a visit. We have 17 days to understand what came calling. Until next time, keep looking up. There is wonder out there, waiting to be discovered. Good night.